you to the second video lecture on projection of lines. I am Tony Punnuswale, Professor from the Department of Mechanical Engineering at Coimbatore Institute of Technology. In the previous video, we have seen a line which is parallel to both vertical plane and horizontal plane. Today we will see a line which is inclined. So in that, this is the first topic, a line which is inclined to HP and parallel to VP. So you can see here a line AB which is inclined to HP. So this is the horizontal plane HP. This line AB is inclined to HP and it is parallel to the vertical plane. So when looking from the front view will be on the vertical plane. Then from looking from the top view will be on the horizontal plane. Now the point which is to be understood here is front view has an equal length to the true length of the line. That is, the front view is A dash B dash, which is on the vertical plane. It will give the true length of the line AB. But the top view, which is on the horizontal plane, will not give the true length of the line. Now if I draw the orthographic view of this problem, we have the XY reference axis. Since it is in the first quadrant, VP or the vertical plane is above the reference axis and HP is below the reference axis. So you can see the front view. It is inclined. So this is the front view, which is A dash P dash. So this is your front view, which is inclined. Then if you draw the projections downward, then this is your top view AB, which is parallel to the reference plane. So you can see in this figure itself, this is your top view that is parallel to XY line. Then this will be your theta, which is known as angle of inclination. Now let's see the So this is the first type of inclination, line inclined to HP and parallel to VP. So AB line is inclined to HP and it is parallel to VP. So you can see the front view is parallel. Then here you can see the orthographic view. Now this is the second case, a line inclined to VP and parallel to HP. So this line AB it is inclined to the vertical plane and it is parallel to the horizontal plane. So if you look from the front view is this. So it is a straight line. From looking from the top, you have this AB as the top view. So here the point is top view will give the true length of the line. So this is your orthographic view. You have the XY reference line. Then you have vertical plane above the reference line and horizontal plane below the reference line. Since front view gives the straight line, you can see here A dash B dash is the front view. It is parallel to the XY reference line. Then from looking from the top, you have the true length. So AB is the true length. That is your top view. Then here theta, which is the angle of inclination. Now let's solve a problem. So this is the problem. Read the question carefully. So we have to draw the projection of a line AB. That is the question. And it is given that AB is 80 mm long. Then it is inclined at 30 degree to HP. So theta is given, angle of inclination. And it is given it is parallel to VP. So that is our first case which we discussed. Problem similar to the first case. Then it is given that the line is 40 mm in front of VP. The lower end A is 20 mm above HP. So point here is point A of the line AB. It is 20 mm above HP. And it is 40 mm in front of VP. So first we have to draw the XY reference line. We have the vertical plane and the horizontal plane above and below the reference line. Point A is 20 mm above HP. So A dash, which is the front view, that is 20 mm. Then 40 mm in front of VP. So top view will be A, which is 40 mm below the reference line. Then it is given angle of inclination as 30 degree. So when a line which is parallel to VP and inclined to HP, the front view will have the angle of inclination, or the front view will give the true length of the line. So we have to construct a 30 degree and draw the true length of the line. So take 80 mm line at an angle of 30 degree. So this is the true length of the line. Then project it, draw the projectors. So you get the top view, AB. Top view will be parallel to the reference line. Then this is your front view. A dash B dash is your front view, which gives the true length. So this is the true length. So A dash B dash and AB has to be drawn with HB pencil. Because that are the output, then remaining you can use 2H pencil. Fine. Say that if a line is inclined to a plane, then its true length will be obtained on the other plane. Now we will go for the third case. So this is a third case. That is when a line is inclined to both the planes. Line inclined to VP and line inclined to HP. So in this case, it is difficult to get the true length of that line on a plane. So there are three methods to identify the true length. First is rotating line method, then we have rotating plane method, then the third method is auxiliary plane method. So studying one method is enough. So we will see how the rotating line method is used to find the true length of a line which is inclined to both the planes. The problem when the line is inclined to both the plane using the rotating line method. So a line AB is given. Which is 70 mm long. So the true length of the line is given. Then point A of the line AB, it is situated at 15 mm in front of VP and 20 mm above HP. And point B is 60 mm in front of VP and 50 mm above HP. We have to draw the projections of the line. That is, we have to find the top view and front view of the line AB. Also, we have to find the inclination angle. So we have to find theta, the angle theta. So first we have to draw a reference line, XY. VP and HP are above and below the line. Now we have to find the projection of the point A. So the front view of the line of the point A is A dash. It is 20 mm above HP. So it is 20 mm above the reference line. Then the top view of the point A is 15 mm in front of VP. So it is 15 mm below the reference line. Now point B we know it is 60 mm in front of VP and 50 mm above HP. But since we don't know the inclination angle theta, it is the point B cannot be approached like the previous problem. Hence we have to draw the locus of the point B dash and B. So the locus of the will be M dash and M. So we know this is 50 mm above the reference line. So somewhere in M dash M we have the front view of the point B. Then again we have to draw the locus of the point B. So this line, let it be M. Now somewhere on MM locus line we will have the top view of the point B. So this is 60 mm below the reference line which is given. Now from A dash take 70 mm and cut an arc on M dash M. Join A dash and that point. So that will be B dash. So this is 70 mm. Now from V dash draw a projector downward. Then it should meet the horizontal line from A point. So this point, let it be B. Now taking A as the center and AB as the radius, draw an arc. It will meet MM locus line at B1. So this is the top view of the line AB. So this is the top view. So this is the top view of the line AB. So B1 is the top view. Now from B1 draw a projector vertically upward straight. It will meet the locus line M dash at B1 dash. Now join A1 and B1 dash. So this is the front view of the line AB. So we got the first part of the problem, projections of the line, top view and front view. Second part, we have to find the inclination. So the inclination of the line AB line with the vertical plane is theta. So you can measure this angle. We will get the angle of inclination theta with the vertical plane. Now to get the angle of inclination with the horizontal plane, we have to draw an arc. So taking A dash as the center and B1 dash as the radius, we have to draw an arc. So the arc should meet the horizontal line from A dash. Then from this point, let this point be B2 dash. Now from B2 dash draw a straight line vertical downward. Now it will meet the locus line M. Now from A join that point. So let that point be P2. Now if you measure this angle phi, this angle, that will be the angle of inclination with the horizontal plane. So if you see this method, rotating line method, we are actually rotating the line at the end of the line. So first we have drawn this A dash and B dash line. Then we draw the vertical. Now we have rotating it. See here, from B to B dash, we are rotating it. Similarly here, from B2 dash, we are rotating to B1 dash. So actually we are rotating a line from the end point of that particular line. Hope you understand this. Thank you.